Thank you for joining me today. In the last video, we discussed average atomic mass and calculations. Today, we're going to talk, what if I give you the average atomic mass and I want to know the percent abundance of my isotopes? And so that's what we're going to talk about. So last time we talked about this first objective. Today, we're going to talk about calculating the percent abundance of elements or isotopes given the masses of the isotopes and having your average atomic mass. So here we go. If you are given the masses of an element's isotopes, you can solve for the percent abundance of those isotopes. So we've looked previously, your average atomic mass is the percent 1 times mass 1, or mass times percent, plus percent 2 times mass 2, so on and so forth. And so if I'm looking for this, it means I don't know my percentages. So I know that I have an average atomic mass, which is on the periodic table, so we know this. I've given you the mass of the isotopes, but I didn't give you the percent abundance, so we put X in there. So A is X, B, I can't just put Y. I mean, I can put Y in there. But then my percent as a whole, the best percent I can have, the best you can do on a test is 100%. So if I would have said this was mass of B times Y, I will then substitute, and I know that my grand total has to be 100%. So I know that X plus Y, the percent of A plus the percent of B has to equal 100%. And if we make 100% a decimal, we're going to make it 1. So X plus Y has to equal 1, and so I can solve this for X, and I get X equals, or I can solve this for Y, I apologize. I can get rid of this Y for B. I know that Y equals 1 minus X. This is what went into here, and this is where this 1 minus X came from for B. So that's how we're going to do percent abundance. You have mass times X plus mass times 1 minus X. This is really important. It's very important you do this step because I see a lot of times I get X minus 1. If you put X minus 1 into this, your calculations are not going to be correct. You're going to get off. Things are going to go up. And it's all just because we confused our 1's and X's. So if you start with X plus Y equals 1, you're always going to get 1 minus X, which will always go there. All right, so chlorine has 2 isotopes, chlorine 35 and chlorine 37. The average atomic mass of chlorine is 35.453. So if I don't give this to you, look at your periodic table. It's got it. I want to know what is the percent abundance of each isotope. I did not tell you a specific mass of 35 or chlorine 37, so use 35.00 and 37.00. So I know I have an average atomic mass, which is 35.453, is equal to my mass 1, which is 35 times X, plus mass 2, which is 37. I should put AMU behind it. AMU times Y. X plus Y equals 1. Y equals 1 minus X. I'm going to substitute this into here. So I'm going to erase my Y. So I have 37 AMU times 1 minus X. And now it's algebra. So from here you have 35.453 equals 35x plus 37. So I'm going to FOIL. I'm going to distribute 37 through. So 37 times 1 is 37. 37 times a negative x is minus 37x. So we're this far. Now I'm going to get everything that has the same, I'm going to combine like terms. So I'm going to get all my numbers the same because of this. So I'm going to subtract 37 to the other side, and I'm going to subtract 35x minus 37x. So if I subtract 37 on both sides, I'm going to get I should get a negative. I'm going to erase that equal sign. Because 37 is bigger than 35.453, I'm going to get a negative 1.547 equals, and 35x minus 37x is negative 2x. So I can get rid of the negatives because I have them on both sides. So it'll be fine. I'm going to divide both sides by 2, or divide by negative 2 if you didn't make them both positive. And you get x equals 0.7735. And that is, I can make that now a percent. So I'm going to move my decimal twice. And I'm going to get x equals 77.35%. I would like 2 decimal places on your percentages. This means that the isotope associated with X, so chlorine 35, is 77.35%. Now I can use my x plus y equals 1, and I can substitute. So I can use my decimal again, or I can use 100. So I can take 1 minus 0.7735, which is going to equal 0. I apologize, I'm running out of space. Should get 0.2265. If you're confident in this answer, you can take 100 minus that, and chlorine 37 is going to be 22.65%. That is going to be your percent abundances for chlorine. So this is going to be your answer. It's very important that you label which one is which so that I know. But that's going to be what we get for answers there. Let's try copper. We have 2 naturally occurring isotopes. This should be isotopes, not elements. We're talking about copper. Copper 63 and copper 65. I want to know percent abundances if copper has an average atomic mass of 63.546. So again, I know 63.546 equals copper 63. So 63 AMU times X plus 65 AMU AMY. Let's try a U times Y. Again, X plus Y equals 1. So I can solve for Y. So Y equals 1 minus X. X, and so instead of this being times y, I'm going to put in there 1 minus x, so I can solve for my percent abundances. Okay, so I still have 63.546, and this is AMU or grams per mole, either way, equals 63x plus 65 minus 65x. Combine like terms. So again, on this side, I'm going to get a negative 2. 63x minus 65x is negative 2x. I'm going to subtract my 65 to the other side. So 63.546 minus 65 is negative 1.454. I can divide my negative 2 across, or I can drop the negative signs on both, either way, and I get x equals 0.727. Ooh. Which means that x equals 72.7%. X went with copper 63, so I know that Cu 63 equals 72.7%. Now to get copper 65, I can either do all of that again and solve for y instead of x here, or I can take 100 minus 72.7, and I can get Cu 65 equal to 27.7%. would be my answer there. So that's working through this. There are your answers. Again, we did that. Now I want to give you a chance to try this one on your own. So nitrogen is what you're going to solve for. Nitrogen 14 and 15 are two isotopes of nitrogen. They have an average atomic mass of 14.0067 AMUs. I want to know the percent abundances of each of these isotopes. Go ahead and pause this video, work through that. When you hit resume, you'll get your answer. So nitrogen 14 should have a 99.33% relative abundance, and nitrogen 15 should be at 0.67% abundance there. If you got different answers, come see me next time you're in class, and we will discuss what's going on and kind of work through where we got lost. To close things out, I would simply like you to tell me what you need to know in order to calculate percent abundance of isotopes. I look forward to working with you through the rest of this unit and through the rest of the year. Thank you for your effort and attention today.